I am Sagar,
And I am Pratik.
and this is our ECS 204 assignment submission. Here, we'll be explaining how we separated the various instruments and the vocals from an audio clip. The audio clip we have taken is from the song Blank Space by Taylor Swift. It is a 30 seconds long clip. We'll mainly be using the FFT or Fast Fourier Transform function designed by Matlab for this task. Please make sure you use earphones while watching this video, as the lower frequencies that we will be playing might not be audible properly through regular speakers. So, we'll start off by explaining the basic idea behind this. The songs that we listen to are nothing but sound waves of various frequencies and amplitudes. What this code here is doing is segregating our desired frequency ranges and playing them back. Different instruments and vocals have different frequencies, hence we can distinguish them. This is done in 3 steps: reading, manipulating, and writing. So now we'll explain how we plan on going about doing this. The first line reads the audio file from the address in which it is stored. The second line uses the length function to obtain the length or the number of audio samples in the clip. The third line calculates the intervals in which we'll find the values of the frequencies and their amplitudes. The fourth line obtains the frequencies by iterating over all the audio samples. Now, what we do is use the FFT function or Fast Fourier Transform function to obtain the Fourier transform of the sound wave, and this stores it in a 3D array which contains the frequencies and their corresponding amplitudes. That was for the first part of the code. Now we'll run it to see the results. So here you can see that we have obtained the length of the clip and 2 arrays: frequency underscore audio and FFT underscore audio underscore in. We'll quickly demonstrate what these arrays look like. Now, the sound wave is a periodic function. So here you can see that in the array FFT underscore audio underscore in, we'll get both positive and negative values. Getting back to the code. Now, we need to work with only the positive half of the values obtained by the FFT function. To do that, we set the negative amplitudes to corresponding to half the frequency values to 0 using this for loop. Here you can see that we have added 1 to the number of samples or length underscore audio because it is an odd value here. Now that we have manipulated the data and obtained our desired set of frequencies and their corresponding amplitudes, we now use for loops again to isolate our desired frequencies, which we have obtained by trial and error method. There are loops. These for loops has the values of frequencies whose amplitudes are being set to 0. We found the frequency sets corresponding to instruments by trial and error method. The instruments used are bass drum, hi-hats, synthesizer, and vocals. We have for loops for every instrument and vocals. What we are now going to do is play the original clip and play every instrument and vocals separately.
Nice to meet you where you been. I could show you incredible things. Magic, madness, heaven, sin. Saw you there and I thought, oh my god, look at that face. You look like my next mistake. Love's a game, wanna play. No money, suit and tie. I can read you like a magazine.
That was for the original clip that we have chosen. Now, we'll start off by isolating the synth. That was for the synth. Next up, we have hi-hat. These processes take some time because the for loop is iterating over a very large value. So, the hi-hats were loud and clear too. Now for the bass drum. That was a lot of bass right there. Now, finally, we'll demonstrate the vocals.
It's 11 o'clock.
So, here we have all the components of our audio clip separated and we played it. That was for the video. Thanks for watching. This is Sagar
and Pratik.
signing off.